Hey guys, we're Group 13 and we are here to discuss types of volcanic eruption. And eternally. The first one of our topics is the types of volcano. There are three types of volcano. The first is shield.
A shield volcano is a type of volcano usually built almost entirely of fluid magma flows. They are named for their large size and low profile, resembling a warrior shield lying on the ground. This is caused by the highly fluid lava they erupt, which travels farther than lava erupted from stratovolcanoes. This results in the steady accumulation of broad sheets of lava, building up the shield volcano's distinctive form. The shape of shield volcanoes is due to the low viscosity magma of dermathic lava. Shield volcanoes are built by effusive eruptions, which flow out in all directions to create a shield like that of a warrior. Active shield volcanoes experience near continuous eruptive activity over extremely long periods of time, resulting in the gradual buildup of edifices that can reach extremely large dimensions. With the exclusion of flood basalts, mature shields are the largest volcanic features on Earth. The summit of the largest subaerial volcano in the world, Mauna Loa, lies 4,169 meters or 13,678 feet above sea level. Most of what is currently known about shield volcanic eruptive character has been gleaned from studies done on the volcanoes of Hawaii Island. By far the most intensively studied of all shield due to their scientific accessibility. The islands lend its name to the slow-moving, effusive eruption typical of shield volcanism, known as Hawaiian eruption.
The second one is cinder cone.
A cinder cone, or also called scoria cone, is a steep conical hill of loose pyroclastic fragments, such as either volcanic clinkers, cinders, volcanic ash, or scoria that has been built around a volcanic vent. They consist of loose pyroclastic debris formed by explosive eruptions or lava fountains from a single, typically cylindrical vent. As the charged lava is blown violently in the air, it breaks into small fragments that solidify and fall as either cinders, clinkers, or scoria around the vent to form a cone that often is symmetrical with slopes between 30 to 40 degrees and a nearly circular ground plan. The rock fragments, often called cinders or scoria, are glassy and contain numerous gas bubbles frozen into place as magma exploded into the air and then cooled quickly. Cinder cones range in size from tens to hundreds of meters tall. Cinder cones are made of pyroclastic material. Many cinder cones have a bowl-shaped crater at the summit. Some cinder cones are monogenetic, the result of a single, never-to-be-repeated eruption. Examples are Paricutin in Mexico, Diamond Head, Coco Head, Punch Bowl Crater, and some cinder cones on Mauna Kea are monogenetic cinder cones.
The third one is stratovolcano.
A stratovolcano, also known as a composite volcano, is a conical volcano built up by many layers or strata of hardened lava, tephra, pumice, and volcanic ash. Unlike shield volcanoes, stratovolcanoes are usually characterized by a steep profile and periodic explosive eruptions and effusive eruptions. Although some have collapsed craters called calderas, the lava flowing from stratovolcanoes typically cools and hardens before spreading far due to high viscosity. Stratovolcanoes are sometimes called composite volcanoes because of their composite layered structure built up from sequential outpourings of eruptive materials. They are among the most common types of volcanoes, in contrast to the less common shield volcanoes, Two famous stratovolcanoes are Krakatoa, best known for its catastrophic eruption in 1883, and Vesuvius, famous for its destructions of the towns of Pompeii and Herculaneum.
Discuss types of volcanic eruption.
Earthquakes near and beneath volcanoes alert scientists that magma and volcanic gases may be on the move. This animation represents generalized patterns of seismic and geologic activity at some, but not all, long dormant stratovolcanoes worldwide during the months and hours leading up to an eruption. We will use an example from Central America to illustrate how volcanic earthquakes are interpreted. These types of volcanoes form where mantle rock located above the subducting plate, not the subducting plate itself, melts to form magma. Melting of the mantle is facilitated by water released from the oceanic plate. Let's zoom in closer to show how moving magma and volcanic gas and fluids trigger earthquakes as they force their way up through the crust into shallow underground fractures, causing faults to move and cracks to vibrate. Different seismic signatures will reflect varying geologic processes. Sample seismograms include deep, low-frequency earthquakes and/or tremor that occur as magma that formed in the lower crust rises into conduits. These deep events can only be detected by sensitive seismometers. An aseismic zone separates the deep and shallow earthquakes. At shallow levels in the upper crust, common seismic events include high-frequency volcano-tectonic or VT earthquakes, shallow low-frequency earthquakes, and hybrid earthquakes just below the summit. Before we focus on the shallower processes, we notice the layers and forces that affect how and where different earthquakes occur. To reorient you, we again cut away the volcano surface to reveal a more detailed view. The crust is separated into an upper brittle seismogenic zone under hydrostatic pressure that has a complex system of fractures and aquifers, and a lower aseismic plastic zone that is subject to lithostatic pore fluid pressure and which shallows dramatically under volcanoes. Along volcanic arcs, magma from previous eruptive episodes cools to 700 to 1,000 degrees Celsius and slowly crystallizes at roughly 6 to 12 kilometers depth. Heat from this magma conducts through the surrounding rock, enlarging the plastic zone. The two zones are separated by a transition of contrasting permeability that prevents concentrated magmatic fluids from escaping upward out of the plastic zone. As the magma reservoir is filled with new magma from below, it becomes pressurized, pushing the crust upward and outward, but may not be enough to rupture the brittle rocks above. This stress change causes distal volcanotectonic earthquakes to occur in the brittle crust at the base of faults near the volcano. Magma tends to rise in pulses. As subsequent intrusions occur, the overlying rock is pushed upward. The increased hydrostatic pressure is transferred long distances and causes earthquakes on distal tectonic faults. A large enough intrusion will cause the transition zone to rupture, expelling stored magmatic fluids. Because pressure above the transition is 2.5 times lower than below, the sudden rupture causes depressurization of deep fluids and results in boiling and generation of low-density magmatic vapor. This process creates low-frequency earthquakes. The rising vapor, mostly steam, may cool as it rises and may not be seen at the surface. After the rupture, mineral precipitation reactions may quickly reseal the transition zone. During a pause between intrusion pulses, the vapor zone can migrate higher into the uppermost part of the volcano. The next intrusion will again be preceded by VT earthquakes and easily ruptures the newly resealed ductile brittle transitions, causing low-frequency earthquakes within the vapor zone beneath the summit. The additional gas pressure may rupture rocks near the surface, causing phreatic explosions. Occasionally, we observe artesian springs issuing from high on the edifice, which may form volcanic mudflows or lahars.
Types of volcanic eruption. Hawaiian eruption.
In a Hawaiian eruption, fluid basaltic lava is thrown into the air in jets from a vent or a line of vents, or a fissure, at the summit or on the flank of the volcano. The jets can last for hours or even days, a phenomenon known as fire fountain. The splatter created by bits of hot lava falling out of the fountain can melt together and form lava flows, or build hills called spatter cones. Lava flows may also come from vents at the same time as fire fountaining occurs, or during periods where fountaining has paused. Because these flows are very fluid, they can travel miles from their source before they cool down and harden. Hawaiian eruptions get their names from the Kilauea volcano on the Big Island of Hawaii, which is famous for producing spectacular fire fountains.
Is the Strombolian eruption.
Strombolian eruptions are distinct bursts of fluid lava from the mouth of a magma-filled summit conduit. The explosions usually occur every few minutes at regular or irregular intervals. The explosions of lava, which can reach heights of hundreds of meters, are caused by bursting of large bubbles of gas, which travel upward in the magma-filled conduit until they reach the open air. This kind of eruption can create a variety of forms of eruptive products: spatter or hardened globs of glassy lava, scoria, which are hardened chunks of bubbly lava, lava bombs or chunks of lava a few centimeter to a few meter in size, ash, and small lava flows. Products of an explosive eruption are often collectively called tephra. Third one is the Volcanian eruption. A Volcanian eruption is a short, violent, relatively small explosion of viscous magma. This type of eruption results from the fragmentation and explosion of a plug of lava in a volcanic conduit, or from the rupture of a lava dome. Volcanian eruption creates powerful explosion in which material can travel faster than 350 meters per second and rise several kilometers into the air. They produce tephra, ash clouds, and pyroclastic density currents of hot ash, gas, and rock that flow almost like fluids. Fourth one is the Plinian eruption. Plinian eruption is the largest and the most violent of all types of volcanic eruption. They are caused by the fragmentation of gassy magma and are usually associated with very viscous magma. They release enormous amounts of energy and create eruption column of gas and ash that can rise up to 50 km high at speeds of hundreds of meters per second. Ash from an eruption of column can drip or be blown hundreds or thousands of miles away from the volcano. The eruption columns are usually shaped like a mushroom or an Italian pine tree. And finally, the last is the Circean eruption. Circean eruption are a kind of hydromagmatic eruption where magma or lava interacts explosively with water. Circean eruptions occur when an undersea volcano has finally grown large enough to break the water's surface. Because water expands when it turns to steam, water that comes into contact with hot lava explodes and creates plumes of ash, steam, and scoria. Lavas created by Circean eruption tend to be basalt, since most oceanic volcanoes are basaltic.
The first type is the radiogenic heat. The flow of heat from Earth's interior to the surface is estimated at 47 terawatts and comes from two main sources. In roughly equal amounts, the radiogenic heat produced by the radioactive decay of isotopes in the mantle and crust, and the primordial heat left over from the formation of the Earth. Second one is the primordial heat. Primordial heat is the heat lost by the Earth as it continues to cool from its original formation, and is in contrast to its still actively produced radiogenic heat. The Earth's core's heat leaving the core and flowing into the overlying mantle, is thought to be due to primordial heat and estimated at 5 to 15 terawatts. Estimates of mantle primordial heat loss range between 7 and 15 terawatts. The early formation of Earth's dense core could have cause superheating and rapid heat loss, and the heat loss rate will slow once the mantle is solidified. Heat flow from the core is necessary for the maintaining the convecting outer core